Morning, everybody. Back in my studio again. We've already talked a little bit about, I've already introduced you to the basic rules of linear perspective in our PowerPoint already. I just want to do a really kind of quick demo this morning to show you how to get started. I will go through the steps that we went through in the PowerPoint, but kind of demonstrate in real time how to do that. And then I will demonstrate how to create the cast shadow shapes, how that works. And then I will conclude by showing us our, introducing our homework assignment that we have. So again, I've already introduced to you the basic idea of when we start drawing, we want to start drawing at the corner that's closest to the viewer, obviously. And then we're going to be dealing with the parallel lines that are converging to vanishing points out on our horizon. So with that simple concept behind, let's get started. First thing you're going to do, of course, is to put a horizon line on your paper. Put it up, maybe 2/3 of the way up. I always like to put my vanishing points, if I have the ability to do so, as far out at the edges as possible. Give myself, it just makes for better configuration of the, that would be vanishing point right, and vanishing point left. So, first thing I'm going to do is go ahead and place that forwardmost corner. It's always advisable not to just put your corner dead center right between the two vanishing points. Move it off to one side or another. So, and I'm just going to, so I get my things perfectly vertical, I'll use my little triangle here. I'll move it off to one side. Give myself, fairly good sized height of the box. So you're going to establish the height of what will be your cube. Then we will use our straight edge that you got in your art kit and trace out to what are called, these are called orthogonal lines, and these can be very light. These are just reference lines that lead you to your vanishing point. Can you see that, Kai? Does that show up?
Mm-hmm.
Okay, thank you. So the first thing you're going to do is top and bottom orthogonals out to my right vanishing point. And again, just light construction lines. These don't need to be heavy. We're going to erase all these early construction lines eventually. So I've got them going out. These two parallel lines are going to converge to that vanishing point. Let's do the other left-hand side orthogonals. You want to be very accurate. Go exactly to your vanishing points. Start right at your corners. Linear objects demand accuracy. So okay, now I've established those two orthogonal groups there. Now we're going to look for and establish our vertical corners of the boxes. Depending on where your view is, you may see more of one side than the other. If you're drawing a perfect cube, it's going to appear a little bit taller. Than it is wide. Why is that? Because in theory, these two corners are further back in space than this corner out in front of you. So it's kind of receding and they're getting smaller as they go off into the distance. So there we are. We've established our front corner and the two right and left corners. Now to complete this, we just go ahead and so that line is parallel with that line and is parallel with the one in the far left right corner there. So those three parallel lines converge to the common vanishing point. Just as this one is parallel with this one and will be parallel with the one in the back. So there's that rule. All parallel lines converge to the common vanishing points. So we get in those third little orthogonals. So there we are. This is how we make things look like they're projecting back into space, correct perspective. So are those lines clear, Chris? Can you see them? Okay. Maybe you want to crop in on that just a little bit. Okay, thank you. So we've already been through this in the PowerPoint, so I just wanted to show you again a little quick live demonstration. I want to talk about how to create cast shadows, because there, again, with linear perspective, there's a little bit of a different formula that you need to follow. Of course, we did our spheres, and we learned that a sphere creates an elliptical cast shadow. So that's pretty much, you just kind of got to judge the ellipse, the dimension of the ellipse, or the degree of the ellipse when you're drawing that. Working with linear perspective, it's a little more formulaic. So now we've got to do is create what would appear to be a transparent cube. So we're going to add some more orthogonals. This line is parallel with that one. We know one back there behind on the back side of that cube is parallel as well. So we're going to go ahead and add that. And again, very, very lightly, because we're going to lose these lines eventually. We're just going to be creating these to dictate where the cast shadow occurs. So now we can see through this box, and we can see the footprint, if you will, of the bottom of the box. Notice, if you will, remember when we were looking at ellipses, when we were right at eye level, we didn't see the actual dimension of the ellipse, but the further below or above the horizon we went down, the greater the minor axis got. Same thing is applying here. You'll notice the minor axis from this corner to that corner is closer to the horizon. And as we go down below, it gets larger. We're going to do a homework assignment that will make that a little more clear. So anyway, the last little step here is to, of course, connect that rear corner. So now we've created what is essentially a transparent cube. How do we, now what's the next step as far as defining the shadow? Of course, we're going to always have a light source, right? We know about having our light source. And if we're working outside, I think I've mentioned this before, the sun is so far away that the rays are traveling to us in parallel. And that's what I'm going to demonstrate this morning, these parallel lines. But the first thing we want to do is give ourselves some reference lines, which will be on the surface that the cube is sitting on. First line we start with intersects right through the two right and left corners. So again, go ahead and give yourself a reference line. You can let it run a little bit long in the direction that the light is coming away, directing away from the object that the light is coming from. So you're going to start with an intersection reference line right between the two corners there. Now these lines are going to be parallel to each other, so you want to make sure. Now we're going to go to the very back corner of that cube and keep that parallel to the one we've already described. I want to make sure that's equal and parallel. Now we'll come to the forward lower corner, put another third parallel line. So we've got these three reference lines on the surface of the cube, below the cube. Now let's define the rays of light and how far. Now depending on where your light source is going to dictate, just as it did with the sphere, the incidence of light will dictate how long or short the cast shadow is. So I'm just going to make a judgment and say, okay, let's start off of this farthest corner left. We're going to say, okay, it's going to come down right off the top of that corner. Here's a ray of light. And it comes down and intersects with that corner, just right down, and that's where it's going to intersect with that coordinating reference line. The one in the back will come off of that. here again, these light rays coming from the sun are parallel as they arrive here at Earth, and it intersects at that corner's line. Then we lastly come out here to the very front corner, give another parallel line to the other two. Make sure I got that just right. That looks pretty good. Okay, so we've got these light rays. Surface reference lines. Now let's go ahead and define where the actual shadow goes. So that's what these reference lines actually define the shadow. So all we have to do is actually connect them, follow out from that corner across the surface up to where this little intersection is, join those two, go from that corner to where this intersection is, and then of course right back behind where that cast shadow will disappear behind the surface of the box that we don't see. So now we've defined the actual dimensions of the shadow, the way that it's cast. So you can see it's definitely a mechanical formula that we use to create that shadow shape. Let me real quick just lay in some values so we see that shadow. We're going to practice this, and I'll talk about chiaroscuro and light logic after I get through this and show you another quick little demonstration, PowerPoint. I know that these long demonstrations are challenging, so I'm trying to keep this one as brief as possible, but I want you to see how those shadows work and how we create those and define the shadow according to where our light source is and according to the configuration of the cube or any linear object that you're working from. A cube's just a basic shape, easiest to kind of explain things with. So now, of course, I want you to work very lightly because, as I've been talking in a lot of our projects, we don't see lines around shadows. We don't see lines around our object. We're going to define these objects with value contrasts. So once you have completed the construction of your cube and its cast shadow shape, then we are going to go back in here, and if it's a solid cube, we're not going to see, no longer is it a transparent shape. We can lose those construction lines that we had. We've worked very lightly, so they're easy to get rid of. Top surface, I won't see that back corner anymore. It's just going to be a nice cube top surface, and we're going to see three surfaces, the two sides and the top surface. And then, of course, if we want, we can go back in and erase all of our orthogonals and our reference lines and stuff. Just go ahead and clean that up. This is what you're going to be working for when you're going to create your fully rendered light logic cube with all its cast shadows and the other core shadows and light logic rules that we apply to everything, not only spheres but cubes and such. So a number of us, when we were doing our bottles and jars drawing, the contour line drawing, I snuck in a little square jar in there, and I know a number of us had that little cattywampus. I love that word, cattywampus, and but that's, so anyway, I'll go back after I completed that and maybe re-emphasize. Well, I'm not going to re-emphasize my lines, because I'm going to eventually just work with chiaroscuro, which all these construction lines will disappear, just for the benefit of clearly seeing what I've done here. So there, that's kind of short and sweet. That's how we build our cube or any kind of linear object. Generally just start, always kind of remember to start with the closest corner to the viewer, and then build away from that corner. And that, I could literally add another cube, push up next to it. I could add another cube and push it up to this side, and they're still going to work as long as they are in contact with this cube on either of those surfaces. They're still going to work from those two very same vanishing points. So I'm going to move on after this demonstration, show you real quick how we're going to be do a little practice homework. We're going to draw a bunch of little freehand cubes. So to get things from getting too distorted, we got what we'd call a cone of vision, which is this 180-degree circle that's out there in our peripheral vision, and everything contained within that circle. Our viewer here, we're looking out at this cone. Imagine you, the viewer, is the point of the cone, and it spreads out. We're going to work within, and if you stay within that 180-degree cone circle, you will keep all your cubes in without getting distorted. So what your homework assignment is going to be is to do 20 cubes, 10 above and 10 below your horizon. Now, we're not going to be using our rulers for this. What you're going to do is start off, we will be doing this little practice homework on our newsprint pad. So I can't remember. So I think if you go ahead and get like a dinner plate or something to give yourself as large a circle as you can, I think a 10 or 12-inch dinner plate would fit well and give you as large a circle as you can. Then bisect that circle right through the very center, equally divided, and that's where your vanishing points are going to be occurring on either side, right on that horizon line, right at the extremes of that circle. At that point, you're just going to take and place, keep these vertical, don't have them leaning one way or another. You'll put 10, make them about an inch tall, maybe 3/4 of an inch. Just kind of arrange them around throughout that circle. There's 5, 6, 7, 8, 9, 10. And then, of course, do the same thing below, 10. These are all forward corners that we're putting down and keeping those, again, as vertical as possible in relationship to your horizon. Make sure they're not leaning one way or the other, as I did with this one. That bugs me. So I gotta fix that. Got a plumb bob built into my eye where I can really see things that are leaning. So we got 5 more. I'm not going to draw all 20 cubes, but I want to demonstrate the approach to this project and to make us aware of a couple things that I talked about earlier. So 5, 6, 7, 8, 9, 10. So, do I have 10 there? Yes. Freehand. I don't want you to use your rulers, and I can tell when you're using rulers to get out to those vanishing points. I want you guys just to learn how to I don't want us to develop the need for a straight edge as a crutch. We can do it when we're using building our cube and our chiaroscuro, so I want accuracy. But ultimately, we want to learn how to freehand draw and not rely on drawing tools. So just kind of like do a visual and create, you know, that goes down to that line. This one's parallel to the one above it, so try to just kind of trace down and define that one. Now we go back over here. And now we've defined those. Now we come down and create that one and that one. If you recall, in my PowerPoint, I demonstrated, put up a little slide that learned to look at the common middle line. I can kind of see in my periphery, if I look at that line, I can see that this one here and the one above it are converging on that middle one. I can see the same thing here. So this is just a really good method for being able to develop your eye to seeing these converging lines. Look at that middle one in relationship to the two outer ones. You can see that they're converging, then your cube is going to be believable. So notice that the lower we get to our closer to horizon, that bottom surface is going to get flatter. We're going to see less of it. That's the closer you get to the bottom, the little trickier it is to get that appearance, but you can see that lower surface as we near the horizon line, we see less of that surface. As it goes up, we'll see more of it. Let's go way up here to the very top. I'm not going to be using a straight edge to look at your homework. I've really kind of, and hopefully this will really help you develop your sense of sight and be able to tell when something looks right. Again, I don't use my rulers to trace these lines, but I can see them if they're not going in the right direction. So as you see, when we get up here towards the edge of our cone of vision, we start seeing a good deal more of the bottom of that surface. It's going further up, we're seeing more of the bottom. And of course the same thing would apply to those below the horizon that are sitting on a surface. They're sitting on a ground plane. These are all up there floating in the air. So I'm going to stop with that one and just do a couple down here. I can see another way to check to make sure that everything's correct perspective is always this forward line is always going to be taller than the two corners that are further back in space. So that's another way to kind of just double check your measurement and make sure that things are correct, is those parallel lines are always going to be converging. And they will be converging as long as this forwardmost line is taller than the two corners that we have. By the time you do 20 of these little boxes, you're going to have developed your eye and your sensitivity towards what is an correct looking cube. So I think that's where I'm going to wrap it up today. I didn't want to make this a long demonstration, so let me go back to Classroom. I'm going to show you one last little quick PowerPoint, then I'm going to show you where that will be posted on Canvas, and we will go ahead and get to drawing. Thanks.